Let's now take a look at the various instance variables and static variables of class SpotOnView. Now, as you saw in the game, we maintain the high score at all times, and we do that by storing that information in the default shared preferences object that's associated with our app. The static constant at line 33 is used to look up that high score and also later on when storing a new high score as well, and we use that in conjunction with the shared preferences object that we pass into SpotOnView's constructor. The next chunk of variables have to do with managing the game. So we have to keep track of things like how many spots have been touched, because we determine whether or not you get a new life based on the number of spots that have been touched. Every single time you touch a 10th spot, you get a new life. We keep track of things like the score and the level, and of course the level is important because we increment and decrement your score by multiples of the level. We manage, or maintain rather, the width and height of our view so that we know the dimensions of the view for the purpose of animating spots to different locations. We keep track of the animation time, which is the duration of a spot on the screen, and that gets shorter as the game progresses so that the game becomes more and more difficult and the spots start to move faster and faster. We also have several booleans here to keep track of whether the game is over, paused, or if there's a dialogue displayed on the screen, and an integer that maintains what the high score was as well. At lines 49 through 52, we create two queues, and specifically concurrent linked queues that store image views and animators respectively. The first of these queues just keeps track of all the different image views that we create and that will be animating throughout the app. And the animators are the objects that are actually managing those animations for us, and we keep track of both of these so that we can do things like add new spots to the screen, remove spots from the screen, and also terminate animations when the user does something like touch a spot. We don't want the animation to keep going on at that point. We want to be able to terminate an animation for that spot so that we can get it off the screen. Next, we have a chunk of variables that just allow us to interact with the various GUI components on the screen and also get access to various resources in our strings.xml file, for example. Then we define a bunch of static constants that represent various constant pieces of information we use throughout the app. So for example, initially the animation duration is 6,000 milliseconds, but that gets faster as time progresses. We use a random object to help calculate the random starting and ending points of a given image view. We keep track of the spot diameter initially of 100, and of course the smaller the spots are, the harder they are to touch. So if you want to make the game easier, you could increase this size, or if you want to make it harder, you could decrease this size as well. We also are setting the scale for the animation so that the width and height of the spots is going to end up being a quarter, 0.25, a quarter of the original size. But again, you can control these values and update them to make the gameplay more difficult or easier, respectively. In fact, you could even go ahead and enhance this game, allowing the user to make such selections so that they can control the difficulty of the game. Initially, we're going to display 5 spots, and there's a delay in between the initial spots being displayed of half a second, 500 milliseconds. You get 3 lives to start, with a maximum number of lives allowed of 7, and a new level is reached after every 10 spots that you touch in the game. The handler called SpotHandler is used to add new spots to the screen after a short delay at the beginning of the game, and you'll see that shortly in a subsequent video. Next, we have the constants and variables that we use to manage the sounds in the game. So you can see, just like in the Canon game, we have a raw folder with 3, in this case MP3 files, that represent the sound when a spot just disappears from the screen because you never touched it, the hit sound when you actually touch a spot, and the miss sound when you touch a space on the screen that does not contain a spot. And then finally, we move on in the next video to our constructor.